Hey y'all, it's me, Mr. D. The D stands for deuterium, and today we're going to be learning about nuclear fusion. In nature, nuclear fusion occurs in the cores of stars, where it combines two atoms together to create heavier ones and a large amount of energy. This not only gives stars a signature shine, but also creates the heavier elements that form rocky bodies and solid mass in the universe. Much like nuclear fission is an incredibly efficient source of energy, and many people want to try and use it to create energy on a commercial scale. This is largely due to the fact that nuclear fusion contains almost zero waste, as opposed to nuclear fission, which carries quite a bit in contaminated water. The main issue with doing this at a commercial scale, however, is the fact that nuclear fusion is incredibly difficult. While fusion isn't difficult in the cores of stars, here on Earth, temperatures and conditions that match those are incredibly difficult to reproduce. But enough about the commercial scaling. How on Earth does nuclear fusion actually work? Both in stars and on Earth, nuclear fusion tends to smash two hydrogen atoms together to create an excess of energy, one neutron, and a helium atom. When done correctly, just a few grams of these hydrogen atoms is enough to produce over a terajoule of energy. You hopefully know from science class that 1 joule of energy is enough to raise the temperature of water that is at 0 degrees Celsius to 1 degree Celsius. And a terajoule is a trillion joules, which is about a 63rd of the amount of energy that was released in the atomic bomb that was dropped on Hiroshima. Keep in mind, that's just a few grams of hydrogen atoms, which are incredibly abundant. But again, what kind of conditions are actually needed to cause nuclear fusion? While the sun's massive gravitational force naturally induces fusion, without that force, temperatures need to be higher than even the sun can create for the reaction to take place. On Earth, we need temperatures of over 100 million degrees Celsius to make deuterium and tritium, two hydrogen isotopes, fuse, while regulating pressure and magnetic forces at the same time to make sure they don't explode. So basically, it's pretty difficult. Difficult doesn't mean impossible, though. Many countries are working together to create reactors that can create nuclear fusion and make more energy from the reaction than they put in to cause it. Nuclear fusion technology is a very promising upcoming source of energy creation, but its implementation will require a lot of combined effort. Unfortunately, implementing nuclear fusion as a common power source is more difficult than you'd think. Though the science is solid, there is a lot of stigma around nuclear power production, primarily because it reduces the need for oil drilling and the previous incidents that happened at traditional nuclear fission reactors. These beliefs are just that, though, stigmas. They're almost completely untrue. Nuclear fission is incredibly safe, and nuclear fusion is not only safer, but it's more efficient. Overall, nuclear fusion is pretty rad. We owe it our lives, and it's a very interesting advent in science that we should start pursuing. Anyways, that's all I got.